All right, thank you so much for joining us today. And in this video, I'm going to walk you through the formulas that you need on the first part of analytical geometry and calculus. That is the coordinate geometry. Now, the best thing is MERB series is having all the formulas, first 2-3 pages of the past question that will be available next semester or when school resumes. And maybe you have the formulas there and you don't know what to use the formulas for. So what I want to do is I want to walk you through all the formulas, the first formulas that we need before we start coordinate geometry, so that if the question is asking us to find the distance between the point, you know the formula already and you know the formula that you need to use, right? So these are some of the tips that you need, right? You need to get the formulas and then everything before we get started. So this video, we have coordinate geometry, we have circle, we have limit, we have derivative, and we have integration. So 5 topics that we are going to learn, but I'm taking them one by one. I'm not mixing them up. So I'll make sure I'll start with coordinate geometry, solve all questions on coordinate geometry. We move to circles in that order. When we are done, then maybe we pick a question which is missed, and then maybe we start practicing from there. All right. I don't want to talk too much, but I think our book, which is coming up next semester or when school resumes, we are now arranging all our questions topic by topic, right? I think a lot of you were having, the idea of like bringing the idea that it's good for us to do that. So basically, we've done that. So stay tuned for when school resumes to grab your Merblin series and grab your Merb series, your guide to success. Let's start. So now we are talking about distance between 2 points, right? So basically, that's what we need, right? So let's assume that we have A and B as 2 points on a line. So this is A and this is B. We want to find the distance here, right? So one way that we can write the distance is we can write something like distance of A and B, right? We can also write it as distance of A and B with like the absolute sign, right? So this is what you are going to get. So if you want to find the distance between this and this, then it's just simple. This is equal to, so we are just revising before we start the actual thing. So we know distance between 2 points. If you don't know, this is an opportunity for you to also learn it. So make sure you stay here with me. We have a lot that we are going to do. So this squared plus y2 minus y1 all squared. Right. So this is the formula for finding distance between 2 points, right? So if I have this point and I have this point and I'm treating this one as my u2 and then this one to be my x2, y2, x1, y1, then x2 minus x1 all squared plus y2 minus y1 all squared. So this is the formula for finding distance between 2 points. But let's assume that one of the points is 0, like assuming we are coming from the origin of the coordinate, right? Let's assume that we are coming from the origin to, let's say, A, right? So origin means that here is 0. And let's assume that this is x and y. Then what will be the distance? So the distance here is going to be distance from the origin to A is going to be x minus 0 squared plus y minus 0 squared. And this is going to give us something like this, root of x squared plus y squared. Very nice. So this is what you are going to get. So we have 2 formulas here. We have one that is talking about the origin, and then we have the general one which talks about between 2 points. So even though if you know how to do this, then basically if you are talking about from the origin, you just do something like this and it will send you to this point that we have here, right? So we will start solving example and we will learn how to use the formulas, right? Good. Questions and which formula I need to use, right? So that is all that I'm going to talk about on distance between 2 points. Let's talk about midpoint, right? Let's talk about midpoint of a line. So we know we talk about midpoint. Midpoint, we are talking about if I have A and if I have B, and we are talking about the midpoint, the point that divide this into two. So let me say that this is the midpoint somewhere here, right? So how do we find midpoint? So that's one thing that we need to also learn, right? So midpoint is very simple. So the formula here is we are going to have the midpoint to be equal to, so remember we have x coordinate and we have the A and then we have the B. They have S coordinate and we have the Y coordinate. So it's very simple. All we need to do is the midpoint is x2 plus x1 divided by 2, right? And then y2 plus y1 divided by 2. So this is the midpoint, right? This is the formula for finding midpoint. So if this is given, the point here is given, for example, let me just pick quick example. For example, if I have A to be 2 and 3 and I have B to be equal to, let's say, 4 and let me say 10, then what will be the midpoint? So let's talk about midpoint. Midpoint of A and B will be equal to, so when you use this one, you're talking about the slope. So let me use midpoint of A and B. This is going to be 4 plus 2 divided by 2, right? And then we are going to have 7 plus 3 divided by 2. So 4 plus 2 divided by 2, which is here, and then 7 plus 3 divided by 2, which is here. Simplify, and we have 6 divided by 2, and then 10 divided by 2, and we are going to have something like this, 3 and 5. So we are going to solve more questions, more difficult questions, which will actually, let you know what we just need to use all these formulas for. So first, don't forget, let me write this one well. Sorry for coming back. 0, this is equal to x squared plus y squared. So this is one of the formula that we are going to use. And then this is also one formula that we are also going to use. Good. So I'm just putting there. And then now we know that midpoint is equal to x1 plus x2 divided by 2, y2 plus y1. Any of them is works. So let me do it 1, 2 here. So this is the formula for finding the midpoint of 2 points. Good. So this is what you are going to get. Very simple. Good. So have them in mind. Let's look at gradient of a line. So let's look at gradient of a line. So when we talk about gradient of a line, we are actually talking about the slope, right? So what's the formula for finding slope? So we are just revising. The formula for finding slope is change in x over change in y, right? So the slope or the gradient, so gradient of the line AB is given by, so it's given by, we are going to do it like this, MAB, which will be equal to, so we know that this is just the change in y divided by change in x. So this is going to give us y2 minus y1 divided by x2 minus x1. Is that right? So this is the formula that we are going to learn with the slope. This is another formula that we need to learn with the slope, right? So anytime the question demands slope, we know what we are looking for, right? And the slope always help us to also look the idea of finding something like let me say equation of the line, which we will talk about. But when we are using trig identity, then we can say that the slope can also be, let me say, the slope can also be tan of theta when we are dealing with angles, right? If we have some angle here and we want to find the slope, we can use the idea of tan theta to also have to get our slope, right? Now let's note something that it is also useful under slope. So when you are talking about slope, we can talk about um, two lines, right? So we want to talk about two lines. Now, another thing that we can see here is we can talk about L1 being a line and then L2 also being a line. There's two things that we can learn here. We can see that now if L1 is perpendicular to L2, then what happens? Then it means that when I multiply the slope, so let me assume that L1 is having a slope of M1 and this is having a slope of M2. Then when this line is perpendicular to this one, then their slope is basically when I multiply the first slope to the second slope, I need to have -1. Very important. This is very important. And we are going to use them a lot when two lines are perpendicular to each other. So this sign here is perpendicular, right, to each other. Then when I multiply the slope, I should have it to be negative. So here, if I want to simplify it, let's assume that I know M2, then M1 will be equal to, or let me say if I know M1, M2 will be equal to -1 over M2. So that's why we said if a line is perpendicular to another line, then the other line will be the negative reciprocal of the first line, right? So that is the idea. So if I know that M1 is 2, then negative reciprocal of 2 will be -1 over 2, which is the same as just writing it like this. Then we can talk about when the line is parallel to each other. So this one is parallel to this. Then it means that the slope between them are the same, right? So we have two lines. So another important thing that you need to also learn here is when two lines. So let me indicate this one. Then this one here, let me write here. This one here is perpendicular, right? Okay. Good. So that is the idea. So basically, these are very important things that we need to know. So as soon as you are reading the question and you see that, oh, the question is saying that this line is perpendicular to this line, then if you know the first slope, then you should be able to know the second slope too. When they are parallel to each other, then if I know the first slope, I should be able to also know the second slope. Oops, I think this one's supposed to be 2. Good. So that is basically another important thing that we need to learn from here before we move to the equation of a line. So one thing about equation of the line is, let's assume that you get your slope wrong. If you get the slope wrong, then basically you are going to get the equation of the line wrong, right? So that is basically what it means. So we saw that the slope of AB was equal to y2 minus y1, which is the same as x2 minus x1. Now let's assume that the slope is general, right? So if the slope is general, let me assume that this is equal to m as my slope. Then equation of the line is very simple. The equation of the line is y minus y1, which is equal to mx minus x1. Very simple, right? And since if we are talking about equation of the line, your x1 and y1 can be any of the points. Since it's equation of the line, you can pick any of the point, right? After using the point here to find the slope, then your y1 and x1 can be any of the point. You can use this, you can use this, any of them quotes. So this is the equation of the line, which is also very important in everything that we are going to do. Calculate the equation of the line, do this. Sometimes we don't even ask you to do the calculation for equation of the line, but basically you need to do that, right? So that is the equation of the line. Now basically we can also write the equation of the line in different form, right? So we can write it by simplifying this, and we are going to have y is equal to m, right? mx minus x1 plus y1, right? And this is the same as mx minus mx1 plus y1, and this is the same as plus c, where c is equal to minus mx1 plus 1 y1. So this one here, whenever you write it in this form, which is also very important, let me just write it here and circle it. So y is equal to mx plus c. This one too is very important. Now remember, this c here now is called a y-intercept. Y-intercept. So we can give you a question where they've given you the y-intercept, and then you just need to find the slope and then form the equation of the line. So this m here is the slope, and then this is the y-intercept. So one thing that also you need to have it in mind, slope or the gradient. I hope you are learning something. Yeah, so basically that is also the equation of the line, right? That's the equation of the line. Now let's talk about division of a line segment into a given ratio. It's very important, right? Which we are going to talk about internal and external, right? So we can divide a line into two, like either internally or externally. And it's something that we need to always do. So let's assume that this is the ratio. We want to divide the line into two. Then what will be the formula? So remember, we are dealing with internal division. So the formula is very simple. We are going to say that this is going to be equal to, so let's assume that we are using R to be our division point. Then this is going to be m1 m times x1 plus n x2 divided by m plus n, and then my1 plus ny2 divided by m plus 1. Here the order is very important. The order is very, very important, right? Because as soon as you swap it, you change everything. Now look at where your n is, right? So if they've given the coordinate, what you need to know is look at how our coordinate is. It is a, b, and then the ratio is n is to m. So what is happening? You can see that all the m is, all the n is multiplying the x2 once. So you can see that actually this one is going with this, or the second point, right? And then our m is also going with this, or the first point, right? So this was x1 y1, and this one was x2 y2. So here the order is very important. As soon as you swap them, you get them wrong. So as soon as the coordinate given to you is of the form a, b, and then m is to n, then it means that now it swaps. M goes for b, and then the n goes for a. So that's what you need to know. So always when they give you this, remember that your first ratio here goes with the second point which is given, and then the last one here goes for the first term that is also given. So that is what one thing that you need to also have in mind. Good. Let's look at the external one. So the external one, the question can be silent. So when the question is silent, they will give you this point here. I mean, if the question is silent, you see minus is to m, meaning that this should divide it externally. But if the question is not silent, then they will say that maybe external division, and they will give you the same ratio as it was given here. But what the clue is now, it is external. So you need to know the formula that you are going to use. So what will be the external formula? Is basically the same, almost the same as the internal one that we just learned here right now. But the only thing that is going to change is what I'm going to show you. So this is going to be, let's say, R open bracket, mx1 minus nx2 divided by m minus n, right? And then comma, we have the my1 minus ny2 divided by m minus n. Now, let me show you some trick here that you need to know. You see that there's a lot of minus there. Now, if you have minus here, this minus is telling you that the thing is external. So let's assume that the question was silent and the question is saying that -2 is to 3. It doesn't mean pick -2 and plug it in here. When you pick -2 and plug it in here, this one becomes positive, which will send you back to internal, right? So when the minus is here, it's trying to tell you that it is what? External. So your n here, when it shows you that your n here is 2, your n here is 2, and your m here is 3. This is your n, which is equal to 2, and your m here is equal to 3. But when the question says external and also still bringing the negative, then that one you need to show it there, right? But basically, if we are dividing something, the ratios are always positive, right? So pay attention to when it is minus. When it's minus, it's trying to tell you that it is what? External. So that's what you need to learn from here. So it's kind of, I need to learn formulas, have all the formulas in mind, so that when I'm doing the things that I'm doing, I know that, okay, this is what I'm doing, right? So it's very important. Distance of a point from a line. So distance from a point from a line is basically something like this. I have this line here, and then I have this one also here. Let me push this one. Good. So this is how the thing is. This is point P, or let me see. Okay, this is the line. Yeah, this is point P. This point P, x1, y1. And then this is the line, ax plus by plus c is equal to 0, right? So anytime you have something like that, what is happening here? We can see that these two lines is meeting perpendicularly. So it means that if I want to form the equation of this line, one trick, if I want to find the equation of this line, remember, equation of a line, we need y minus y1, which is equal to mx minus x1. So y1 is here, x1 here. The only problem here is I don't know my slope. So remember, since this line is perpendicular to this line, then I need to find the slope for this one and then pick negative reciprocal of that and then plug it in here. Is that right? So that is basically, you will solve examples on that, you understand it better, right? So that is one thing that you need to also know from here. Now the question is, what is the simplification of this formula? It's very simple. So what we want to do is, now we want to find distance between this and that, right? And for us to find the distance between this and that, remember, this point here is on this line, so we can just take it from there. So here, understand, when we are talking about distance between 2 points and a distance between a point, or a distance of a point from a line, we have different formulas for that. So what's the formula that we're going to learn from this one? We are saying that the distance between P and D, right, this distance here, is equal to absolute ax1 plus by1 plus c absolute divided by root of x squared, a squared plus b squared, right? Remember, when we started at 101, we said absolute is working like plus or minus. So I can write this one as plus or minus, open bracket, ax1 plus by1 plus c or divided by root of a squared plus b squared. So very, very important. What did you see here? You can even see that this is what we are writing here. But basically now we are not using x and y because we don't know x and y. But we are using x1 and y1, which is basically here. So here we are assuming that x is equal to x1 and then y is equal to y1. We plug them in here. Divided by root of the coefficient of x and y, all squared. Square of that plus square of that. So that is distance of a point from a line. We will take more examples in the next video and you are going to understand that. Now, with the idea of angles between two lines and then equation of bisectors of an angle between two lines, it's kind of basically this one. If we are doing them, basically we think of like using something formula like this and then we just do them, right? So basically we don't have exact formula that we are going to use for of equation of bisector of angle between two lines, right? But when we solve more example, I will show you what we are going to do from there. Now with angles between two lines, like we are talking about angles between two lines, right? So we are covering something like this. This one basically, that one too, we don't have particular formula that we need to just learn so that we can use it to do something like angles between two lines, right? But when we are solving examples, I'll talk more on that, right? And then we will look at how we are going to go through those process. So don't forget, we've gotten a lot of formulas here, right? So don't forget, we have this formula here. This is distance of a point from a line. Good. This one is formula for finding the external division, right? Good. And then this one is for the internal division. We have equation of the line with the y-intercept form. And then this is the equation of the line, the general one. And then we learned that if two lines are parallel to each other, then they have the same slope. If they are perpendicular to each other, then when I multiply the slope, I should have -1, which is the same as this. Then we look at the slope, right? That's the same as the gradient. And then we look at the midpoint between 2 points. Just add the x coordinate, divided by 2, add y coordinate, and divide by 2. And then we looked at distance from the origin to a point and the distance between 2 points. So this is what we've learned so far. So this is like under coordinate geometry, as I said. So what we are going to do is in the next video, we are going to take examples and then we practice. Find the distance, find this, and then we practice together and then we go. Now in the next video, this is what I want you to do. Grab your pen, grab your book, and let's work together, okay? When you are learning here, try to pick a pen and just try to be doing something and learn something new every day, okay? So that's what I want you to do. So we are going to start the next video. That's when we are going to start practicing. And when you are done with this one, with the practice example, and we see that, okay, we have touched everything that we've talked about in this video, then now we can move to circles. All right. See you in the next video.